Okay. Hope that you can hear me at home as well. So, yes, that is a bit funny. Okay. So, not sure we need that yet. I'll put it down in a minute. Yeah, I think so. Okay. Can you hear me back there? Awesome. Okay, so hello everyone. It's awesome to have all of you today with us. This is the first meetup of 2026 of the Web3 Devs Underground. So first comers, welcome. It's great to have you. And to the rest of our community, it's great to see you again. Today we have a special guest. We're going to start with Stephen Goldfeder, the first lecture of today. Some of it will be broadcasted, some of it is just for you guys. And then directly after that, we're going to have Amir from Space Computer to tell us more about how you do blockchain in space. And as a physicist, I love it. So hope it will be as interesting as I hope it will be. And thank you everyone for coming today. I want to tell you a little bit about our community before we start. So just a short intro. We're the Web3 Devs Underground community. We're a nonprofit operating from Israel and in Israel. And a little bit about us. So we were founded about 4 years ago by Shauli Rejwan, who is here in the back. Thank you, Shauli, and Roy Osherov, who founded this community. Thank you so much. About 4 years ago on open source values. And it was basically a meetup for developers and builders that grew up. And today we're doing lectures with one of the biggest names in the space. So we're hoping to continue on that front. So just a moment. Okay, so just some courtesies. So to stay in the loop, and if you're not yet a part of the communities, and for the people back at home, I would encourage you to get into our website at web3devs.org and get into our community, start interacting. We would love to have you with us. And that's it. Without further ado, I would love to present our first speaker of today, Stephen Goldfeder. Thank you so much. The mic is yours.
Thank you.
Yeah, for the questions part. No worries. Okay, so hello everyone from home. Now we're willing to also add you as well and ask some questions. So just a moment. Okay, Stephen, the mic is yours again. I'll play with there, but questions, guys. Feel free.
Speak loud. Yes. Yes. So the question was, for those at home also, like I gave this sort of general startup advice, and a lot of the points I gave were widely applicable to, generic in the sense that they're not crypto specific. But do I have any specific advice for crypto founders and Web3 founders? Yeah, I'd say one piece of advice that I give that I see people falling into this trap often is a lot of times in crypto, you'll find investors that really like to have deep control over the economics of the projects. And that could be like, particularly because crypto has this token model, which gives like, early liquidity to sometimes that, many industries don't have. And it often leads to very complex structures and structures that often like founders don't want. And I would say that like, if you're like, do the best you can to get yourself the absolute, fewest restrictions you can before taking capital. And the sense is like, you don't want to take capital that says you have to launch a token in your product by X date, or your token has to be distributed like in this and that way. Like the earliest thing, like in a crypto project, like you might have some ideas, but like any other project, like when you're early on, you have no idea how things are going to turn out. And again, this is true for every project, but I've seen particularly related to tokenomics, like a lot, some investors give like very, very prescribed rules of like, you have to follow these things in ways that actually ties people's hands very much later on. So I'd advise you to try to steer clear of those. And, the best investors don't do things like that, but just honestly, be aware of that. It's something that could be relatively dangerous. And otherwise, like, I think a lot of it, is generic. I think crypto is just another industry, just like, a part of tech today. I think it's a part of finance today. And we have to view ourselves as, just like any other startup. So the question was, what is the thought process that goes on in your mind before doing a major pivot, right? So the truth is that, like, despite what I just said, like, we've done like small pivots, many small pivots, but like if you actually look to the earliest version of Arbitrum, and this you can look on YouTube, and you'll find a YouTube video from the fall of 2014, Princeton semester. I think it was January 2015. The video was published. And by the way, the reason I like to mention that date is because that was 6 months before Ethereum network went live. So Arbitrum has been, like, at least in Ed's mind and others at Princeton, very, very early on, before there actually was a smart contract platform. You'll find that a lot of the core ideas, so the bisection game that we do today, for example, you'll find that a lot of these core ideas were actually there from the very beginning. But there were also a lot of things that, of course, changed over time, like how the system works, the longevity of the system, right? We thought of it initially as more short-term interactions rather than like long-term chains. I don't want to get too technical in here, but the point I was trying to make is we actually like have not pivoted that much compared to other startups that have started off as like doing industry A and going to industry B. But to me, the point is, and the thing that I said on the slides, which I think is important, is you have to constantly just question yourself: is what I'm doing today, I'll be a little more general than I was on the slide, is what I'm doing today the absolute best use of my time? Right? Is this what do I still think that this is what I can be doing best to improve the world, assuming that's what you want to do, to make the world a better place, or whatever it is your objective is that makes you tick, that makes you that you want to spend your time doing, because everyone's time is limited. Hopefully we have a lot of it, but ultimately everyone has a limited amount of time to make an impact in the world, or achieve whatever it is that they want to achieve. Is this the best thing that I can be doing today? And if your goal is to scale Ethereum, is this the best way to scale Ethereum? I think that's the question that you have to have, because so many times, like, you see people that are they're working on startups that, like, everyone on the outside can see is just like a dead end, but like it's just hard for them to get out of the inertia of, like, they're doing this today because they're doing it yesterday. And I think that's the mindset to get out of. And it's really very industry specific. Like, it's hard to say what a pivot is, like how you should do it. But ultimately, the question is this the best use of my time today? Is this the best use of my team's time today? Is this the best use of my investors' resources today? If the answer to that question is no, say to yourself, well, okay, what is it that I think I should be doing? And that could be something as simple as a product or project level pivot. And it could be something like as simple like, or as difficult as, I think I'm in the wrong industry, and I think that the ideas that I had a couple of years ago might have been right back then, have proven to be wrong, or I've proven not to be able to execute like I thought I was. That's a hard thing to admit to, but it's okay. Let's pick up, what can I be doing today that will accomplish the same objectives that I wanted to accomplish years ago, or whatever my renewed objectives are. So the question was, well, thank you. And the question was, what is Offchain Labs currently looking for projects to invest in? And if so, what type of projects do we invest in? So the answer is yes. We have an internal fund at Offchain Labs called Tandem by Offchain Labs. And we, out of Tandem, we both invest in projects, and we also sometimes on a more limited basis, but actually build alongside projects as well. There's an Israeli company that's that is in the second category, a company called Phoenix. Some of you may be familiar with, where we do more deeper collaborations than just invest. In terms of the things that what is our thesis? What are we investing in? Like, what type of projects are we interested in? It's very much the things that we want to influence in the industry, and we want the industry to build and have. We think that the industry needs, right? So it's very focused on our core mission, which is make blockchains accessible to everyone. And the things that we think that the industry needs, but we either feel like we don't have the resources to build ourselves right now, or we're, for whatever reason, better off not building ourselves, but we want this thing to exist. That's like the very general core thesis. Like, this is an important project. And it could be like, that the product itself, or it could be something more research oriented. We think this is important work. Like, the world needs this work. But we think we're better off actually not building it as a first party. Those are like, generally the things the type of projects that we invest in. Sure. The culture of Offchain Labs is very academic. And what I mean by that is, well, it kind of feels like an academic lab in many ways. So it's collaborative, it's friendly. Sorry, the question was what in terms of the culture at Offchain Labs is unique in terms of the points that I presented. So it's academic, it's friendly, it's collaborative. It's not like easy in the sense that people have like high expectations, and you're expected to perform and do your job and do well. But ultimately, like, we're not breathing on top down people's necks in terms of like no one's clocking in. If you need to go somewhere or need to work later on because you need to like take care of your kid, like, it's very flexible in terms of like when you do your work and how you do your work. But obviously, there's a very high bar on Offchain Labs. I think we have some of the best the best people in the world working with us, and but it's also, again, very collaborative. What I mean by that is the good ideas can come from anywhere, and we recognize that, and there is no ego in ideas. So if you are, and this has happened in the past, you can be a brand new employee at the company and you think that, hey, I actually think you guys are doing this all wrong. And I'll go up to one of the founders of the company, myself, one of my co-founders, and say, hey, I know this is your idea here, but like, this could be a technical idea, it could be something else. This has literally happened with technical ideas early on in the company. Like, this is wrong, guys. We got to change this. And the idea is like, there's no ego that says, well, who are you? Like, sit back down. I'm gonna like call the shots here. It's like, I actually want to hear that. I want to, and often we've actually done company-wide pivots based on individuals' ideas. I can give you two of those examples. So I mentioned Arbitrum Nitro before in my talk. So we launched Arbitrum 1 with the AVM to the public on August 31st, 2021. If you actually look at the Arbitrum Nitro repo, it was about 6 or 7 days later that we started building that. And that actually started, which is kind of crazy if you think about it, right? If you think about it, like, we just launched this. It was like the first general purpose L2. The liquidity was like going up, and we're already thinking about like, okay, what is the next thing? How do we do this better? So that's like an important thing as well, constantly questioning our assumptions and not saying, hey, just because we built this yesterday and it works, like literally yesterday, like just because you built this and it works, like we're done. It's like, no, how can we do it better? That's a constant thing, not being complacent with where we are. But also, it didn't actually start off as a company priority. It started off as a single person's side project where they said, I'm going to build this out. And, after a week or two or three, it was like, hey, I think he's onto something. And then slowly it became something that the company shifted into, but really inspired by a single engineer. Yeah. So the question was like, are there any like events, either crises or positive events we've had, and how we sort of reacted to those, and planned from there. again, we've obviously, I think we've been very fortunate. Thank God we've had, not too many crises in our time. But ultimately, like, you can, depending on your mindset, anything can be a crisis, right? So um, the competitive landscape, for example, of Arbitrum has changed, significantly throughout the many years that we've been building it. And it's easy to say, and it's easy to say, like, okay, it's crowded now, it's hard, but like actually continue to ask ourselves, like, how do we differentiate ourselves? How do we continue to build? How do we make sure that Arbitrum is not only like, winning today because it was winning yesterday, but how do we make sure it's actually has the absolute best feature set there? I think is something that's, very, very important for us. I'm thinking about like the intersection of, particular incidents that I can both speak about and also would be insightful. But generally, I think ultimately, probably the one I mentioned before about early on, like the lack of ability. Like there was really like there is an alternative universe in 2020 where Offchain Labs shut down because we couldn't get funding, and the idea is that what did we do? We wouldn't take no for an answer because we believed very fundamentally that we had something to offer to the world that was just better than anyone else. And even though no one else saw it yet, this was like during COVID, we were on probably 20-hour days, like, and I can make myself and my co-founders and others in the company were literally on 20-hour days trying to spread Arbitrum's love to whoever, and the mission and what we believe is special about it to whoever would listen. And if the ultimately like the ship was going to go down, it wasn't going to go down for less lack of trying. And that's ultimately we were successful, but really it's not giving up, I think, is the core. We've been, there will always be up and downs. There's this concept of a book called The Infinite Game, which is you're always playing a game, right? Sometimes you're ahead and sometimes you're behind. And the only way to lose is actually to stop playing. So the core idea is you have to just keep playing. And when you're behind, not say like I lost. And when you're ahead, not saying I won, but understanding when you're ahead, there probably will be a time where you are not ahead by as much as you are anymore. And what can you do to maximize your lead now, so to minimize the effect that later on? And when you're behind, realize it's okay that I'm behind because I'm still breathing and I still have a chance to go ahead. And the only thing that will stop that is to me to get it so into my head right now that I'm behind to actually, give up, which is something that I think is in our DNA. We don't give up. We don't always necessarily, not everything is a winner on the first try, but we believe in what we're doing and we don't give up and we keep trying until we can't try anymore.
I think you've mentioned before that we're now part of the big tech industry and we're part of also the finance industry. Can you give us a bit of your perspective on the current adoption from, here at Checkpoint we secure a lot of the big financial institutions. How does it come to play today, and how do you see the near future in terms of adoption and going forward?
Yes, the question was how we see the near future and beyond when it comes to adoption by general tech, in particular like financial institutions and fintech companies, something like that. Okay, I think we're at a really interesting point in our history here as an industry, where for the first time, it's not the first time we're seeing fintechs and large funds build things on the blockchain. Actually, you can go back like 4 or 5 years and you see this, but a few things have changed. If you go back to like the 2017 and 2018 era, often it was like blockchain in name only, in the sense that people were building on what we called like private blockchains or consortium blockchains, but they weren't actually building on public blockchains, and they didn't actually appreciate the value. I remember actually in that era being in a conversation with one of the largest banks and saying to them like, hey, I think that like there's value to the public blockchain. And they just like, they didn't understand. Like they just literally didn't understand. And I'm like, no, but it's like provable. And like, I was like speaking into a vacuum. It wasn't like for lack of trying, and it wasn't like malice. They just like literally did not appreciate at the time the benefit of what we had to bring. And there's a lot of education that we've done for that, and we've done as an industry. And it's not just us at Offchain Labs or in the Arbitrum ecosystem. My friend Sandeep at Polygon is probably one of the best BD folks in the world, and he's laid a lot of the groundwork actually in his conversations for a lot of the conversations that we're having today. We build on each other's successes, and he's continuing to obviously do that as well at Polygon too. But like the idea is that we really work together. It's a big pie, and together we're able to really educate. So that's number one. People today, the industries today, number one, they recognize there are benefits of public blockchains, and number two, they often recognize that there are particular benefits of building on Ethereum. That's something which we should not take for granted. But number two is, I think the other big shift of what we're seeing today is in the previous era, it was you might have a big institution that's doing something on the blockchain, but it's like a side quest, right? So I have my real thing here. That's my business. And now, like, I have this little thing here that I don't really care about. Maybe I got some like large grant or whatever to do it, and that's my blockchain project. It was kind of a throwaway. But we're seeing for the first time is big businesses, actually like fintechs, large institutions, not just like have a little blockchain thing, but actually take their core business and bring their business on chain. I think there's no better example of this than what we see from Robinhood, where they're actually saying, like, we believe that blockchain is the future of equities. It's the next level of evolution, right? Equities started on pen and paper, and here we are today in the system that we have, in the digital system we have, and the next system is actually going to be blockchains. And the idea is it's not this side quest. We're saying we believe that this is the future of our industry. And you actually see this cross-pollination happening where companies like BlackRock and Franklin Templeton and Wisdom Tree and some Invesco, some of the largest funds in the world, are taking their funds and putting them on Arbitrum and other networks as well. And you see also people taking blockchain projects and bringing them to traditional investors via ETFs or via DATs. And we're seeing this cross-pollination where crypto is becoming not just like this like side thing. It's actually becoming a fundamental part of the financial landscape. And that is something which is a large shift. And to go back to Robinhood for a second, if you're using the Robinhood app in Europe today, and you want to buy a share of Apple, and you're using the Robinhood app in America and you want to buy a share of Apple, they'll look almost exactly the same. From a user, they will feel pretty much exactly the same, but there's a big difference. In America, you're actually holding that share in a brokerage, but in the US, but in Europe, what's actually happening is that equity you bought, that share of Apple, is actually a tokenized share of Apple on the Arbitrum network. But the coolest thing is that the users don't even need to know that. The users are using crypto. They're getting literally the benefit of their experience is fully powered by crypto, but they're not like engaging with crypto in the way that we might thought they'd have to. They're not setting up a wallet. They're not remembering a seed phrase. They're not like engaging with any of the difficulties, if you will, of crypto. And that to me is so, so, so powerful. So the fact that number one, in Robinhood's case, it's their core business. It's not like a side quest. And number two, you have millions of users that can now use this, and hundreds of millions of users that can use this platform and not even realize they're using crypto. That to me is very exciting. And if you zoom out, what I think is going to happen over the next year, 2 or 3, it's no longer going to be like TradFi, traditional finance, and DeFi. It's just going to be this thing we call Fi or finance. And it's no longer going to be like RWA. It's just going to be this thing we call assets. And assets can be on the blockchain, and assets can be off the blockchain. But ultimately, they all make up a single unified financial system where blockchain infrastructure is just another very integral, but another part of that system.
Going back to the very early days of Arbitrum, do you have any advice on choosing a co-founder or co-founders and building a great culture with the initial employees, the founding team?
Yes. So the question was, going back to the early days of Arbitrum, do you have any advice on choosing a founder or co-founders and how to build the founding team? So the truth is here, like, we are very lucky. We have the equivalent of like a high school sweetheart, if you will, because by the time we founded Arbitrum, I'd been working with my co-founders for 5 years already. Ed was a professor in our group at Princeton, and Harry and I were both PhD students at Princeton in the same group. So there really was very little risk in the sense that, like, I knew these people very, very well. We knew each other well, and we knew that we worked well together. That being said, there will always be disagreements among co-founders, and that's actually healthy. If you all agreed on everything, like, you're probably not doing anything very interesting, right? The interesting things are the controversial things. You'll have disagreements, but the important thing is that you have to remember is not to take it personally, And also, it's okay to be overruled. If you say you have 3 co-founders, 2 is a bit harder, but if you have 3 co-founders and 2 of them believe one thing, you believe another thing, defer. It's okay. Like, fight your point, argue, but if you still, like, you can't get to agreement, like, that should be your agreement. Okay, like, I lose this one. We're going to do it that way. And I'm not going to, like, begrudgingly go into, like, the next meeting. It's like, okay, that's the process. I trust these guys. They disagree with me, but, like, I'm able to understand that we're all trying to get to the same place, and we're going to go with that opinion. Again, if you feel very strong, you can continue to fight. But the idea is you fight, and when the conversation's over, you move ahead with gusto as if that's your own idea, but you don't let, like, oh, I have to work on his idea now, or I have to work on her idea now, but, like, this is not what I want to do. Like, don't let that take over, because if you do, that won't be good. But ultimately, yeah, I don't, for better or for worse, my co-founders were very known entities, which is, by the way, also something which is valuable. If you have people that you work well with, that's always great. But obviously, that's not available for everyone. And there's nothing wrong with trying things with new people, but try to get to a place where you're aligned on a vision. And you don't have to be aligned on the method of how to achieve that vision. You're going to figure that out. But as long as you're aligned in a vision, like, there should be no disagreement that you can't overcome. Any last questions? Okay, well, thank you so much, everyone. This has been wonderful. I really appreciate your time.
Thank you so much, Stephen. This was wonderful and inspiring. I would like to do a short break and do a stop for thanking the sponsors. So, Dan, if you would like to present the checkpoint. And before then, I would love to also present Master Key. We're starting now the live and the rest of the meetup. This part was Stephen's, let's say, surprise for you guys that came all the way here. So I'll present Master Key if you don't mind. Master Key is the sponsors of today's night, and also myself are working at Master Key. So Master Key is an early stage VC that specializes in infrastructure and deep tech in the Web3 space, operating across the big crypto hubs with around 16 world-class cryptographers and several other industry experts. That's it about us. And Dan, the stage is yours. And after that, you can all stop and eat some pizzas and some beer, and we'll continue to the next lecture of today with Amir.
Okay. I don't want to stand between you guys and the pizza, so I'll make it short and sweet. I'm Dan. I lead the blockchain security team here at Checkpoint. For those who are unfamiliar with Checkpoint business, as I mentioned, we secure some of the biggest financial institutions in the world, and following them, we got into the blockchain space, securing digital assets in real time. We do real-time security for both wallets and smart contracts. Our biggest claim to fame today, I think, is our amazing team. Most of them are here in the crowd. I'm very thankful for Master Key and for the underground community to come here. I see a lot of familiar faces that I haven't seen in a long time. Yeah, thank you all for coming, and if we can support you guys, the community in any way, please feel free to reach out directly. Thank you.
Okay, thank you so much, Dan. So now we're going on a short break. Take some beer, take some pizza. We'll be back soon with Amir's lecture. בדיוק, יש לך גם למעלה שם שתייה, אם אתה רוצה. טוב, מעולה, אני איתך, אז אני גם אלך להביא מים. מסתדר?
Good. I want to introduce you my friend.
Nice to meet you, man. עברית, אנגלית. Whatever you prefer, guys. It's no worries.
Sorry for being late.
No worries, man. It was interesting, though.
Oh, yeah?
Stephen, in the last minute, told us he doesn't want to broadcast everything. So we're trying to fit with that, but no worries. We respect his wishes as well. Just a moment. I'll shut this.
Starting. So today we're going to talk about how is it like to build distributed systems and blockchain in space. some challenges that we are facing there, and also in general about our journey and how we resolved some of the challenges that we faced. Not working. Okay. Okay. So my name is Amir. I'm based in Israel. Started my journey 12 years ago, something like that. Did my software engineering degree in Afeka. I worked at SAP, mostly in my Web2 life, previous Web2 life in the cloud domain. I was an architect as well. After that, SSV network, for those who know, hardcore P2P, our consensus protocols, protocol, things like that. And afterwards in Chainlink to see a bit like the industry from my level. And a year ago, almost a year ago, I moved to Space Computer. Here we are doing, lots of interesting things, building blockchain in space. So yeah, it's lots of distributed systems and consensus protocols. We have a lot of confidential computing, TEs, things like that. And we're in space, so space communications, this is something pretty important. So I guess you all heard about like the space boom that there is right now with the space data centers. We have Elon Musk and Jeff Bezos behind, and the companies behind them are pushing towards space, and also Google is in this race. In general, it seems like the space is open now for business. There are more startups, and people are building interesting things. And just in the last recent years, you saw a massive growth, an exponential growth of the number of satellites that we have up there. And there are very cool companies that are being established right now and establish their business. We have Starlink, Kuiper, which changed its name to Leo, Amazon Leo, which is for communication. And we have things like Rideshare, where you can actually deploy multiple satellites with the same rocket. And we have some like hardcore infrastructure providers that are building space stations in space, aiming for long-term solutions to be there. And it all looks pretty cool and nice, but yeah, it's like crypto 10 years ago. So lots of PR, lots of branding. There is not so much behind it, because eventually when you compare the cost to run something on Earth or in space, you get to a massive like 10x difference, which is it's not practical for all the hype that we see right now. But this is like just today. So it seems like we have lots of challenges to resolve, and until then we are not there. But as an industry in general, and also us as a company, you need to crawl before you walk and walk before you run. So why we are building now in space? Basically, we have the physical isolation that it's a pretty special feature that no one has, and no one can jam us. Basically, you have something running there, nothing would stop it. And this is what's special. And today we're going to talk about, again, like our journey, the things that we learn as a company, dealing with those things. 1 second. And eventually, how we plan to resolve our issues. So first, regarding, let's see where we are. So we're talking about LEO, low Earth orbit. Other orbits are pretty high and might be a bit impractical with regards to latency. And the low Earth orbits, LEO, in short, is something like this is also what contributed to the number of satellites. Basically, you have smaller satellites and more of them. and they are pretty cheap comparing to higher orbits. And eventually, the latency, communication latency, becomes something more practical to do real life systems. And the lifetime, usually like it's 5 years, but we saw also cases of 1 year, something very short, something just if you want to test things. It's also cheaper to launch there, but also things which are more longer term. But this is more or less like the lifetime of the machines that of the satellites. So one example that we are working with is called CubeSat. You can see here it has like wings, and these are the solar panels. And here you have like slots that you can put your compute payload. And basically, it's like a host for multiple. You can put there multiple payloads. And this is the SpaceX rideshare. And this is the transformer. Here you can see that there are multiple batches of satellites. Eventually, it launches to space, and all of these are being launched in different orbits. And eventually, you get to save the cost of the launch like that. And yeah, so regarding space communications, we're talking about we have space to ground stations, and we have satellites to ground stations. We have satellites to satellites, and we have satellites to other. It could be planes, it could be ships, it could be whatever that we have on Earth. Currently, the major trends, laser beams. I think this is the most trendy thing, also called OISL. Basically, think that the initial communication type was just radio. With these lasers, it brings something new to the game with the bandwidth that you can have and the latency. But it also introduces lots of challenges. We'll see in 1 minute. And we have some other cool stuff that are currently being worked on. And hopefully, yeah, the integration with the terrestrial networks that we have on Earth, that would be something pretty cool. And yeah, this is also like in the roadmap. So in 10 years, for example, we could talk directly with satellites from our phones, with systems that are running on satellites. And if we dive a bit more into how it's actually being deployed, what are the orbits? So for LEO communication networks, you have several constellations which are possible. The first one is Walker Star, where you can see that the orbit is in this direction. The satellites are covering the poles as well. They are covering all the area. You have Walker Star, where you have a better distribution in, let's say, in residential areas of the Earth, but on the poles you have less coverage. And you have a mixed geometry, which covers all. And it's also like a function of how many satellites you have in your network. So let's look at Starlink as an example. It's the most dominant player in the field. It has more than 7K satellites, and the number is growing. Right now, I put the January 2026 in the first slide. So in half a year, you would see double, probably. And they use mixed geometry from the previous constellation that we saw. And this is possible because of the number of satellites. They have enough. And they are currently like targeting more residential markets. So they provide connectivity from anywhere. You have like a good example in the last weeks in Iran, where they were able to bypass all the government limitations. But eventually also this was jammed by the government. So it's also, we can see also the bad sides of it. And yeah, they are using laser beams. So this is like their factor, I guess, what makes them different from others. The dish itself is pretty user-friendly. Very easy to set up anywhere. and it's like reducing the need for the massive ground stations that we have with radio. So for CubeSats or for small satellites, it's still not there. It's an issue. The challenges are too much for it. So first, the weight and the high power usage, and these are the two most the main issues, let's say. But afterwards, you also have like a vendor lock. So, for example, if you want to work with other solutions, other Leo networks, you probably won't be able to do so. And they have like a different use case. So they are meant for terrestrial networks. The entire satellite to satellite communication is something like a retrofitted feature. It's not something they natively thought about and wanted to do it. And yeah, and they are pretty, you can say, customer first. They don't mind about reliability as much as other solutions. But this is the future. So, and also, by the way, like from last week, also for us, we have some change. So Starlink are really pushing towards controlling the markets. So you would be able to see like their solutions also after they resolve the issues. And until then, hey Kitty. Until then, we need to work with what we have. So the alternative is to use a radio frequency, and basically we have two options. We have ground stations, and we have other LEO satellite networks, and this is how it looks like. So us as we have something on the satellite and we want to communicate, for example, with the ground station. You can see actually in the picture, but there is also like antenna that needs to be pointed to the ground station. And in this example, the antenna needs to be pointed to the satellite that you're talking with. So it's not like straightforward to have these two antennas at the same time. But generally, this is one example here. I took Iridium network. We will go over them in 1 second. But you can also see that because they're flying in some height, in this case 700 kilometers, we need to fly below them in order to use them as a communication network. So it's also like a limitation. And yeah, I was talking on Iridium, because this is eventually one of the options that we chose to go with one of our vendors. So it's an old network. It's pretty resilient. It contains 66 satellites, a completely different number comparing to Starlink. But it also like serves different. It serves different markets. So it's also like a fully meshed constellation. Like you don't need ground stations theoretically, and it provides global coverage. If we remember that constellations image, then it's the Walker star, the first one. And yeah, you can have communication in remote locations anywhere, also in the poles. It has like a band spectrum that enables you. The first band is you as a user. It's their service link. So you as a user, when you interact with some Iridium satellite, this is the band that you're working with. It's pretty resilient, but the bandwidth is in kilobytes, and this is like me. That might be even the number might be like very low, not even in kilos, but yeah, it is what it is. The K band, this is what they use for their internal communications. And they have also a band to interact with ground stations and gateways that there are on Earth. And this is the most like a strong band, and bandwidth can reach to gigabytes. And they expose like several services that you as a user can use. And the most basic one, this is called SBD, short burst data. And it's like a unicast communication point to point. You can specify some target device. And hopefully, with the help of the Iridium network, the message, the packets would hop until it reaches where the other satellites is, and yeah, the exchange messages. You can see that the payload is pretty small, and this is why I mentioned, yeah, it's like bytes, like 270 bytes. This is like without any headers, without anything, and this is unencrypted channel. So we need to apply encryption on top, and we need to put our headers inside, and yeah, it's let's say this part is not so fun. But the cool thing about it, like from a user point of view, it's low cost to operate, low power. And the burst service is something more expensive. Let's say if you use it, it could be more than 10x even in the price comparing to SBD. But it provides you like broadcast communication that you don't need to implement anything on your own. You rely on Iridium to send the message to some specific geographical area, and every satellite that would be in that area in specific point in time, or let's say in a specific period of time, would get the message. And they have also a cloud solution, so you can actually send messages without talking with any ground station, without like, let's say, the space infrastructure complexity, just with Amazon, and it's pretty easy to do, or easy friendly for a developer. But eventually it relies on the same services, so the latency is pretty high. I didn't mention latency, but yeah, everything is seconds to minutes, might be even hour. So yeah, the numbers are a bit impractical. So we can do like an hybrid solution where we are using several services to send some message that we want to maximize the delivery of that message. And with ground station, it's a bit different. You have like windows of operation, like every hour you would get, for example, you pass over 4 ground stations. So each time you pass over the ground station in some radius, you have connectivity to that ground station, so you can downlink or uplink. And it's for larger chunks of data, so we don't have that limitation with the 270 bytes, but something more like 10K. And it has, like, as I said before, it's like several antennas that you have on the satellite. And basically the ground station one, yeah, it's being balanced. So when you don't over some ground station, it stays off to save power. And the most annoying thing about it is to try to interact with those ground stations on Earth and basically send some message. You need to have like pre-allocation. You need to prepaid and have allocation for your interaction with the satellite, or with the ground station, more correctly. And yeah, and there are queues, and the delay might be like it could be weeks sometimes. And from the satellite point of view, I think that it's also like we, as, let's say, as one of the guests on the satellite, we interact with ground station, but also the satellite itself needs to interact with the satellite. So you have like also like a band for if you need to have some commands that you need to send to the satellite, if you want to see some health status and things like that. And we have the S-band, which is mostly for us, that we can download large chunks of data and also to upload. The distribution of the ground stations is not so, let's say, at least for me, I was sure that there are more. There are not so many. And Amazon also has like a pretty strong, they are pretty dominant on that field. And we also have lots of ground stations near the poles, because apparently there they have like better better connectivity. And on the satellite itself, what do we do like to interact with the antennas from our board? So there is something called CubeSat Space Protocol, CSP. Basically allows you to, us as a subsystem in the satellite, allows us to connect to different components. And it comes with like a pretty cool feature set. And basically they try to give us the same look and feel that you have with TCP stack on Earth, but from within the satellite, within the boundaries of the satellite. And in our case, yeah, it would be to connect to different modems and antennas. And just to recap, so again, we have communications with Iridium or other communication networks. And this is for low speed, but more constant and resilient connection. And we have it ground stations, that's higher bandwidth, but it would be not constant, not all the time, just in Windows. And there we have, of course, higher bandwidth. And if we go a bit like into the compute payload, what we actually, let's say, what is the environment that our stuff are running there? So our stuff is the mission computer, which contains some board and some peripherals that we connect to. In our case, we will see it later, but we have some security elements that we are adding on top of the satellite, on top of the board in the satellite. And we have the OBC. This is like from the vendor side. It's like, you can think of it like, yeah, it do telemetry and power. Basically monitors the system. We have a cooling system that basically use so it's space. We will get to it in a few slides, but in space you can't just fan out the heat. It's not gonna work. It's a vacuum. So what they do is to use like metal straps, and these straps touches the chips and cool them down. This is how the you have some like hydraulic solutions, but this is the most used one, and it's not good as the things we have on Earth, and it's also consuming power. And last, we have the communication modem. This is like, let's say, a component that we also get from the vendors. And we need to connect to. This is how it looks like. On the left side, you see the stack of boards. And this is how it looks like when it being wrapped with some box. And this is the, let's say, if you want to look on high-level architecture, this is how it looks like. So we have some EPS to manage the power, not just for our board, but for the entire satellite. And it takes the power from solar panels. And eventually that modem, yeah, it helps us to communicate with antennas we have on the satellite. And theoretically, we could also have sensors that, let's say, are more, that they have something that we want to get. One example is to get randomness from space. This is one offering that we have. And our main problems there, so the power is pretty limited, like, and we might need to work like in duty cycles, like not being on all the time, or not do some compute, at least with some percentage. So yeah, we need to be ready for power blackouts in general. The payload size is pretty limited, also the weight. So what we put there is also something that we are limited with. I mentioned before regarding the heat, and in general, temperature is very volatile. So if you're exposed to sun and you're not exposed to sun, it's more than 100 Celsius degrees difference. And bit flips, this is something that could basically fry your entire board or hang your CPU. So there might be cases, you want, like, by design to have the control to shut off the system and turn it on, but it might not help in some cases. So think that in your RAM, there might be a case where some bit got flipped because of radiation, and then it could mess up the entire, for example, if it's something important, something critical, let's say something in the operation system, in the kernel, then you might be lost. Like, from our point of view, it's like, we will see it next, but it's like, for important things, for critical things, we need to use storage with redundancy. So if something happened, we can always get back from it. And vibration. So think that the satellite is moving like fast, like it does normally. Like it's like 90 minutes orbit to circle around the world. So yeah. So the vibration is something pretty problematic. If you use USB, just so you know, it's highly sensitive. You need to have like some shifturim for it to make it work. Another thing is that you need to trust the providers. So theoretically, they could say, yeah, we launched your hardware on some satellite, it's in the orbit, but it could be in their garage, I don't know. So it's like we need to have a way. Currently, we don't have anything to be sure that, okay, what we sent you, the actual components are the ones that are in the satellite, and you didn't change them. For example, we have a blockchain, so there might be like sensitive stuff, so they might push their software, their hardware, whatever. So yeah, it's an issue. So how we survive? Let's say the main line is, yeah, we need to reduce the computation that we are doing and the communication between nodes, and all of that while maintaining the security features of space. So from hardware security, we have a layered approach, where first we have a TPM, a Trusted Platform Module, and this is like the root of trust from our point of view. It would bootstrap the keys for the TE, for example. We also use HSMs, hardware secure modules, and for example, we offload key management and signing and cryptographic operations to HSMs. What is not supported within those HSMs, we offload to the TE, and we implement like some sort of extensions of what is supported from the HSM. We do secure boot for all the components in the game, and yeah, it helps us to verify that our software, our hardware is now running, and no one has been tampered with until it reaches the space. And we have something called satellite execution assurance, something we're developing. Like, you can think of it like a space certification. It's a protocol for our software to prove that it's running on some satellite. And we use multiple providers. So by using multiple providers, you're reducing the risk. If there is some malicious employee in the company that we're working with, that's fine. But to have multiple of those in multiple companies, this is less probable. And also it reduces the risks from a technical point of view. So with some vendors, let's say the launches might be delayed, or the launch itself might not go well. So yeah, we need to be prepared on many fronts. This is how it looks like from architecture point of view. So the same picture from before, and I just put like our stuff in the middle. We call it Space Fabric. And yeah, these are the security components that I mentioned before. Another thing about the systems that we are building, we try to keep the hybrid architecture, and hybrid in the sense of having nodes running both in space and on Earth, and to have an hybrid system that eventually we can, for example, have some flow without having all the satellites taking part. And yeah, one example is threshold signing or multisig. And here in the picture, we can see, for example, if we have 4 signers and we need 3 just to for an operation to sign something. And the first one on the right corner is in the range of the ground station, and the next one is not. So we can still operate because we found one. And another thing is with regards to blockchain. So yeah, the L1 that we are building in space, it's very limited. It's running in a very constrained environment. It's not something that we can, it's not something that can be practical and usable without something below that would help to scale it. So a layer 2 probably is a must. And we plan to have also a data availability layer to offload everything about data to on Earth nodes, and yeah, reduce all the dependency on the L1 nodes as much as we can. For the L1 itself, by the way, the chain itself, the consensus protocol, it needs to be highly optimized with regards to the number of bytes that we are sending all around. And it should survive also like blackouts, either communication blackouts or power blackouts, but it needs to survive it. So we must have data dissemination to separate, let's say, the data from the consensus itself, and also to have linear communication. So all the, let's say, most of the protocols that are being used these days, they have a message complexity that does not fit space, does not fit the limitations. So yeah, we need to work around that. And we have like we call it a trust minimized gateway. It's a gateway to space, to our systems, to space infrastructure. So yeah, it simplifies the interaction for users. And from our point of view, it acts as an API gateway to the services that we have on the satellite, and also, for example, as an RPC endpoint for the L1 that we have there. And we decided to do something special, so we run it also in a TE to make sure everything is confidential and the logic is verifiable, so anyone can use it and trust it. So eventually, it would be the one that would take care. Let's see this picture. So this component would take care of encrypting all the communication. So essentially creating a secure channel with the satellite. And yeah, basically, again, be like an entry point for our services and network. And the TE is for others to trust us. But eventually, this is something that we plan to run like in a decentralized mode, where users themselves are running it. And then we have them exposed to our space infrastructure. But yeah, in any case, this is how we see it. And yeah, and that's it. So if there are any questions, I'll be glad to answer. Yep.
What kind of consensus are you envisioning? Like, I wonder, like usually people like you have longest chain consensus, you have BFT, and I wonder if space like affect the decision.
So the question was whether we have some, let's say, opinion regarding our consensus protocol. So I didn't fully understand the.
For example, Bitcoin has like a proof of work longest chain consensus, but the chain builds like you have livelihood, small livelihood, but you have like times.
Okay.
BFT protocols like just don't agree. So I wonder if all the security becomes.
Okay, so it's touching several points. So let's say first, let's see our settings. So it's not like a normal BFT settings. It's something else. In our case, it might be more like a crash fault tolerant, at least at the beginning. So this is one thing. We don't need to be fully BFT. And the other is that we need to, as I mentioned, we need to survive power and communication blackouts. So from our point of view, the algorithm needs to be sleepy or to support sleepiness of some of the components. And it has lots of things to do with, for example, leader election and things like that, and eventually how you advance your chain. I'm not gonna go deep into it. We can do like a lecture just on that. Yeah.
Yeah. So, what do you think is better to do on satellites, and what's smarter to do not on satellites regarding to blockchain components?
So I would say, yeah, if you have like large computations, this is not with like a large input size and things like that. That's not the case. First, and maybe let's go back. Only sensitive stuff, like the stuff that are really crucial. At least for the beginning, this is like our also in my first slides I mentioned why space, because of the physical isolation. So the security feature that you get from something that runs in space is something else from what you get on Earth. But also then you need to think, okay, the important stuff in let's say the critical path, or if it's touching keys and stuff like that, let's put it on the satellites, and the other parts of the system can be on Earth. And if we be more concrete, so for example, let's take some for your wallet keys even, okay? So if your wallet keys would be in space on some satellite, secured with a TE and HSM, you would be able to trust the satellite to sign transactions in your name. And basically it's like paving the way towards autonomous systems and stuff like that, because currently in the blockchain industry that we have on Earth, everything starts with some user interaction. And then the user hold the key, or the other companies that are behind the tokens, let's say the SEX or the whatever platform the user uses, might hold the keys. But in this case, yeah, you can just delegate the entire key management, signing, operations, anything to the space if you secure it properly. So yeah, it's another thing. This is why we have like this layered security approach, where we provide like the strongest security features that you would ever get. And for that, yeah, you also need to run there things that would need that security. If it's something irrelevant, just do it on Earth and that's it. Like, yep.
So first, a request for clarification, and then
Mhm.
if I got it right, then a question. So first, you mentioned the hybrid node model. Is that referring to the L1 and the L2 with?
No.
Or are you going to? That's for the L1.
So if you look on the picture again here, so it's like to have your system distributed across space and Earth. You can say, okay, the multi-tier blockchain, it's also like the derivation of that, but eventually what you have there, it's like different layers. Here it's like the same layer, and with L2 and L1s, it's like different layers of operation. So the L2 doesn't need the L1, for example, to get transaction from some user and put it in a batch, right? It just need L1 to send the batch and confirm, okay, this was submitted. But
the question based off of that is then how do you ensure that the network doesn't prefer certain of those nodes, either the Earth-based or the space-based, and is fair to them, fair incentivization, fair distribution of rewards?
So how do we let's say keep fairness as part of the story when we run in space? I think that before fairness, we first need to be more to have a practical solution. I assume like once we have a practical solution that is working, then we can think about fairness, because right now it seems a bit far from us. First, we need to have something concrete and working. But yeah, those things I agree. We need to think about them, and in general, like incentivization. Yeah. Another one.
Maybe another question. What is something that you can do only in space that is like a use case that's unique to working with satellites?
That's a good question. And actually today, again, you can do lots of stuff in space, but eventually, like what's the value you get from it? And eventually the economic incentive, if it's not high enough, then you wouldn't do it. So in my opinion, as of now, today, these days, I think like the price does not worth it yet. But we are building towards it. Like again, the space industry is booming. I think the prices would go down, and once it would go down, then it would be very appealing for everyone to start do it, because again, you get like security features that you wouldn't get anywhere. And for example, my favorite use case is maybe let's go back. For example, any threshold ceremony that is being done with nodes in space, it gives you like extra layer of security. That one, in order to compromise your system, it needs to be Superman. So
if I understand correctly, like there are things that make this so that the only way to breach this like encryption is getting physically to the satellite.
So our protocol needs to be good enough, but if we do good work, then yeah, that's the case. Yeah. For example, and okay, maybe I didn't mention it, but we're building something. We're sending something to space. What we are designing and building now should be also, for example, quantum proof, and should be like using cutting edge cryptography, not using all stuff that would be deprecated soon. So we also look on those things. Yep.
So first of all, just a comment and then a question. I remember like one of the first examples that I came across of like distributed systems was SETI, like the search for extraterrestrial. So it's really cool that now there's distributed systems in space. That's kind of cool. Yes, my question was just, you mentioned sensors. I'm just kind of curious, like what kind of sensors you're thinking about, what kind of data you can get.
So I'm not sure if it's chilling or not, but I'll just tell about it. So right now we have something. Sorry. The question was, what are types of sensors that we have there? What type of data we take? So one good example, it's called CTRNG, Cosmic True Random Number Generator. From the sensor point of view, it would be like taking snapshots of space radiation instead of, who was it? I think Cloudflare, that are taking snapshots of lava lamp. So this is stronger, and yeah, and I think it's like it's just the first use case for us. But eventually, when I think about the future, the way I see it, there would be lots of autonomous systems in space, and it would be nice to see how we integrate with them. And it might be not just like on the communication layer; it might be more. Let's see. But yeah, it's for the future. So. Yeah.
You said that a lot of security issues in crypto come from like having keys that like side things that start user interaction. But what I wonder is, with the satellites, how do you remove the element of user interaction? Like, what are the use cases where, for example, you have signing, but you don't have like a human controlling that?
I was just mentioning like future use cases of autonomous systems, but eventually, as of these days,
It seems like if you want to get rid of the access and someone from else, like if someone can access the server from else, then the security is still at else. So like, what are the kind of use cases that can happen independently, autonomously and securely?
again, this is like what?
Repeat the question if you can.
So again, sorry for the. So you're asking what are the use cases? So you're saying that because of the, and this is like maybe for this example. Mm-hmm. So you're saying someone might manipulate our system to sign something in the name of. Essentially, eventually you have the user is the endpoint, is the edge, right? So if there is something there, I agree that if it autonomous use case is something maybe like I mentioned, it would be in the future, let's say. But for now, no, we don't have anything autonomous. We have, let's say, another service that we have on the satellite. It's KMS. And this is an example for something that I believe would be soon. We would enter the autonomous use cases. What, sorry? Key management system. So think of, let's take AI agents, for example. So you could have a KMS in space. It would store the keys that would be used by the agent, and no one else could ever put his hands on those keys. If you had them on Earth, someone would try to steal them because it depends on your agent and what it can do with them. But eventually, if you put it in space, then yeah, you're pushing it far away from malicious sectors, and eventually you make the entire thing more secure. So thank you everyone for having me.
No worries. Okay, let's go with it. כבר נסגור. טוב, תודה רבה רבה אמיר, זה היה מרתק. חבר'ה, לפני שאנחנו מסיימים, יש לנו... Oh, yes, so in English. Before we finish, if anyone in the audience wants to come to the stage, present anything, tell us about something he wants to share with our community, this is the time. Feel free to share with us. And yeah, thank you so much, Amir. It was a pleasure. And yeah. Someone wants from the audience to share something with the community. That's it. Okay, so thank you so much, everyone, for joining us today. We're the Web3 Devs Underground. And yeah, we'll see you next time. מה אתה אומר? בטח. בדוק, בשביל זה יש לנו עזרה. מתחילים לקפל מוקדם.